Welcome back. Here we're going to look specifically at the inverses of trigonometric functions. If you remember back to algebra days, when we are talking about an inverse, we are talking about interchanging your x and y coordinate places. So what this means is that your graph is no longer a function until you restrict your range. Okay, remember the range is like your y values. Well, when we're talking about trig functions, now we're talking about an interval. Okay, so if you remember, we have the coordinate planes and we have the 4 quadrants. So here we're talking about restricting our quadrants so that you have an angle that has to fit within your restriction. Okay. So we of course have the majors, sine, cosine, and tangent. So if you look at this first one, we have y equals sine to the negative first power of x. So what this is talking about is this is saying the inverse of sine. So here we have to fall within your restricted range. Well, in this case, we are talking about pi over 2 and negative pi over 2. And so for your sine, we are looking only at this side of your circle. Okay, so this highlighted piece right here. So this is the side that we are looking specifically at. So what this means is that we have a range here where we are restricting ourselves from negative pi over 2 to pi over 2. Okay, so if you think about it, if we start here at 0, pi over 2 means we're going to come up to 90. Negative pi over 2 says we're going down to 270, but we're using just this positive side. Okay. Now, when we talk about cosine, again, we are talking about restricting ourselves, but in this case, we are talking about going from 0 to pi. So here we are restricting ourselves along this positive circle up here, okay, going in this direction. So this means this one is going to have a range where we are going to start at 0 and we're traveling to pi. So we're just going to be in this upper part of the circle. Okay, and so this is where your inverse is going to be. Now when we talk about tangent, we have a couple of issues. Tangent is going to be very similar to sine. However, we cannot include your pi over 2 and your negative pi over 2. So instead, we are still looking at using this part of your circle. Okay, just like with your sine. Only notice we have these open circles here. So in this case, when we have our range, we use parentheses to show that it is not included at pi over 2 in the positive or negative, but that this is the restriction that we are working with. Now with that, we also have restrictions for the other trig functions, or as we sometimes like to call the minor functions. So these would be the cosecant, the secant, and the cotangent. Okay. So for the first one, if we look at the cosecant to the inverse power, okay. Well, what we have to remember here is we have to remember that the cosecant to the inverse of x is going to be the same as the inverse sine of 1 over x. So with that being the case, we can still include our pi over 2's, but what you're going to notice is that here at 0 we now have a problem. So here we would include pi over 2 up to my 0 and then from 0 down to my pi over 2. So if we're looking at its range, again, we would start at the negative pi over 2. We would travel to 0, and then we would go from 0 to pi over 2. So when you're writing these, a lot of times you have to think of the way we wrote the domains when we were in algebra. The only difference is here, this is actually going to be the range because we're dealing with the inverse. Now this next one we can look at, we can call the secant of your inverse. So again, just like with cosecant, we need to remember that your secant to the inverse of x is going to be the same as your your cosine inverse of 1 over x. So it's going to be very similar to cosine in that we're going from 0 to pi, only we also have an issue, and our issue occurs up here at pi over 2. So for here, we're going to go from that pi over 2, we're going to go down to pi. And from that pi over 2, we're going to come here down to the 0, but we're not going to go anywhere else. So my range here is going to go from 0 to pi over 2, union pi over 2 up to pi. Now notice, or you need to remember from everything you do, you're going to go from your smallest, most negative up to your largest, most positive. Okay, so be very careful when writing your domains and ranges. Now obviously the last one that we have here is the cotangent of your inverse. And just like before, your cotangent to the inverse of x is going to be the same as tangent inverse of 1 over x. And it's going to, this case, we're going from 0 to pi, but we have issues at 0 and pi. So here we're going to start at 0, we're going to come up, we're going to go all the way over, and then when we get over here to pi is where we have an issue or a problem. And thus our range here is going to go from 0 to pi. Now, the other thing that we can do with these is we can actually use these examples in order to calculate or find your inverses. So the first one is I have cosine inverse of 1/2. Okay? So the first thing you have to do is you have to look at is this falling inside your designated area? So we want the inverse cosine of 1/2. So here, what you can do is you can actually use your calculator to help find the values that you are looking for. Okay, simply because we have the inverse function on that calculator. Alright, so if you get your calculator out here, we want to do the inverse cosine of 1/2. So the first thing you always want to do is double check. First thing we want is we want to find our degrees. So we can find our degrees here. So once you have it, since it's highlighted, I'm in degrees. So you can go ahead and quit out. So here I'm going to go ahead and do second cosine, which will give me that cosine to the negative first. And then my angle here is 1/2. We're going to close it and you're going to hit enter. So this right here is going to be my degrees. So we're looking at 60 degrees. Now the other piece we need is we need the radians. And so whenever we want radians, we want to have the actual pi measure. So this is where your unit circle, which looks a little bit like this one, is going to come into play. Okay, so this would be considered to be a complete and detailed unit circle. And with this unit circle, what you can see is here in the middle I've got the degrees. Okay, on this outer ring here we've got the radians, and then furthermore out here we've got our coordinate points. Okay, so everything you need to know is kind of right in one spot. We already found out that we were 60 degrees, so when we're looking at that, it's going to match up here to pi over 3. Okay, so the easiest thing to do a lot of times with these problems is to find what your degrees is, and as long as they fall directly on the unit circle like we knew the 60 would, then you can match it right up automatically to be pi over 3. So in this case, we would know that we have 60 degrees, which is also the same as pi over 3. Now, furthermore, we also know that the 1/2 here was falling inside your cosine. So if you remember our trig here, we've got this is part right here, this upper part of circle going from 0 to pi. This is where everything exists for your inverse of cosine. So again, we wanted a half. So if you look very carefully, you could definitely see that if this was your 0, and of course we're going up, my 1/2 is going to fall inside the given angle, and so we would be good to go. Okay. All right, now this next one, we want to have the cosecant of 2. Okay, so remember when we're talking about cosecant, we're talking about this piece right here. Okay, and so we're talking about making sure that this is falling in exactly where it's supposed to be, and so we want the cosecant of 2. Now remember, we also know that to find the cosecant of a value is the same as doing the inverse sine of 1 over that value. So here we would also be looking at doing the sine of -1 of 1 over 2. So this is what you would do in your calculator. So here we're going to pull our calculator out, and we're going to do now the inverse sine of 1/2. So we're going to go second sine, and we're going to do 1/2 and hit enter, and notice here we're going to get 30 degrees. Now again, just like before, we can take out that unit circle. So let's go ahead and take a look at it here. And we want 30 degrees, which has a measure of pi over 6. Okay. So here this would also be pi over 6. Now, if we didn't know that, the other way that you would find it is we would simply have to use the rule. So remember, you could use your conversion rule, which says you would take your degree and you would multiply it by pi over 180 degrees, and then you would reduce, and that would give you your radians. Okay, so when in doubt, you can also do it this way. Now the next one I want to look at here real quick is tangent inverse of -1. So for the tangent, because this is one of our major ones, we would simply be able to just plug it in exactly as is. And so here we would do just that. You could pull out again your calculator, and we are going to do second tan, gives you that inverse, and we want -1. Close it and hit enter, and so here you get a -45 degrees. Now that being said, we could look, and if you remember, when we were talking about tangent, we were talking about the inverse tangent being just on this side of our unit circle. So here I want negative 45. So this is the 45-degree line, but I want negative 45, which is actually going to come down here. However, please don't get confused. I'm not actually talking about 315. I'm talking about 45, which means instead of this being 7 pi over 4, we're actually looking at a negative pi over 4. Now, that can be really confusing for a lot of people, so what I like to say is this. Stick with what we know. I'm sitting here and looking at my 45-degree measure. To match it up, I get pi over 4. Okay? When you go back to your problem, just simply remember this was negative. So if I have a negative degree, it means I have to have a negative radian. Okay, fairly simple, not a lot of work to go with it. Now, in these last couple examples, it says to use a calculator to find each of the following in radians and round to 4 decimal places, and in degrees, round to the nearest tenth of a degree. Okay? So here, we're going to have to use our calculator in 2 modes. So first, my calculator is already in degree mode. So simply all we have to do here is we just have to put it in exactly the way that it says right here. So I'm going to go second sign, and then I'm going to type exactly what I see, negative 0.6199, close it, and hit enter. We're going to round to the nearest tenth, so here we get negative 38.3 degrees. Now I need to do my radians as well, so here I have to go to mode, come down to radians, hit enter, notice it switches over. I can exit out of my mode, and essentially I'm going to do the exact same thing, only now I should get a radian measure. And so here this is going to be negative 0. Round to 4 places, so 6686, and the little r stands for radians. Let's look at another example here. We have the inverse secant. And so remember, this is going to be the same as looking at the cosine inverse of 1 over whatever your x value is, and my x value here is going to be 1.1677. So here I'm going to stay in radians, and I'm going to go inverse cosine 1 divided by 1.1677, close it, hit enter, and there is your radian degree measure. So this is going to be 0.5426. The little r stands for radians. You then need to switch your mode back over to degrees. So we're going to go to mode. We're going to come down, highlight degrees, hit enter. Then we can exit out of that, and here we're going to grab what we just did, so highlight it, hit enter one more time, and now it gives you a degree measure. So here this is going to be 31.1 degrees. So there you have it, a little bit in terms of your inverse trig functions. Okay, what you should notice about them is that most of them is calculator work. So as long as you know the range that you're supposed to be working in and you have your trusted calculator, you should be able to calculate any exact value that you need. So if you have any questions, please let me know. Or if you feel the need to see some additional examples, let me know that too, and I would be more than happy to work them out. Otherwise, it's been a pleasure, and I'll see you next time.